Okay, my name is Rich Howard,
Geralba.
and today we're going to work on pinning Schlage AL series locks. That's what we're going to work on. And the AL series locks are Schlage's grade 2 lever designed locks that came out certainly in the early 90s and have been their grade 2 staple lock since then, when Americans with Disabilities Act was passed in 1990, or thereabouts, I think late in 1990. It was an absolute change overnight, from people walking in ordering knobs to walking in and ordering only levers. Knobs stopped being used at that point, and they were never used again. At least people coming in and asking for them. So the Schlage AL series lock is something that we sell a lot of, and today we're going to work on not only disassembling the lever from the stem, but we're going to actually repin the lock and talk about the concepts of basic pin tumbler cylinder technology, along with how to actually rekey it. We're going to change it to a different key. So let's get that process started. I don't want to have that up there while we're doing it, but so why don't you grab, actually, you know what, I think we will. Grab a lock out of the box that's there. Yeah, you go ahead and you grab one out of there. And I've just realized that I need to get a key for us to key it to. You go ahead and you pull one out.
The box?
Yep. So that lock, that case has six lock sets in it. And they are heavy, there's no doubt. Okay. So we have this AL53, and the Schlage catalog is going to define for us the different functions. A lot, as I've been taught, can be derived from a part number. A part number will tell you the series of lock from the manufacturer. It'll tell you the manufacturer. It'll tell you the series of lock from the manufacturer. It will tell you the grade of the lock, and there's 3 different grades of locks that we may have touched on last time. There's grade 1, grade 2, and then grade 3. Grade 1 is considered heavy duty. It's the heaviest duty lock that's made. And when I first learned about grade 1 locks, it would have to pass a cycle test of 1 million uses. Although I think that number's changed to 500,000 now. To 800,000 uses now. So literally the lever has to work 800,000 times. And if it passes that, it will certainly pass. And they literally have a contraption that will test the durability of the lock. And locks are tested in many other additional ways as well, so that they can gain proper certification from ANSI, let's say, the American National Standards Institute. Well, this is a grade 2 lock, which means it has to, it was 500,000 cycles, and now it's 400,000 cycles. So it has to work for 400,000 cycles. Grade 3 is significantly lower. The point of the matter is grade 1 is what you'd use in heavy-duty commercial applications. Grade 2, like this AL series lock that we have from Schlage, would be used in standard duty commercial, or what they would call heavy-duty residential, but standard duty commercial. And then grade 3 is residential locks only. So we can derive the manufacturer, the series, the grade. We know the AL series is a grade 2 lock, past 400,000 cycles. You can derive from it, from the part number, other things such as the finish, such as the type of latch bolt and strike plate that are included, the type of keyway that's included as well, any keying that's been done on the lock, or you might augment or append or truncate the part number to be very specific about special requirements. Let's say that this lock was built for a door that was 2.5 inch thick. That would certainly be inferred in the part number. So a lot can be told from the part number. What we're working on is just really garden variety material when it comes to Schlage AL series locks, with the only exception that we have this lock in particular. A lock can be derived from a part number. So the latch is an 11088. I'm going to show Geralba that latch in a moment. The strike is LLL. This client literally requested the locks to be shipped with an 11088 latch bolt, but the LLL means less less strike plate. So there's literally no strike plate in the box. There's a minor credit back. This is an 11088 latch, and what's special about the 11088 latch, and in the Schlage catalog, if you were to pull up the Schlage catalog, there are two primary back sets that are common. So a back set is the dimension from the edge of the door to the center of the hole. And that's really, it seems like it's not even important to talk about, but it's incredibly important because the distance, if you think about your bedroom door and it's got the lock in it, well, if you took the lock off, there will be a hole inside through the door. It's called the crossbore. That crossbore dimension is generally 2 1/8 of an inch. You have to not only locate that hole at the proper height from the top of the door down, but you also have to locate it at the proper distance from the edge of the door to the center of the hole. Okay. There are many different back sets. Well, not many, but there's more than the common ones. The common ones for residential are 2 3/8. The edge of the door to the center of that hole is 2 3/8 of an inch. But back set is actually measured from the center of the door, and I'm going to make a quick little sketch here so that we can illustrate what we're doing. Let's actually do it right here. So here's our door. Looking down at the door from a cross-section perspective. Here's our door in elevation when you're looking at your door. So this is as if you're looking down at it this way. The dimension from the edge of the door to the center of that hole is what's called the back set. From the center line, CL, and CL is drawn like that, generally, typically. Anyway, the center line. Before you send someone a lock, you have to find out from your customer, what back set do you want it at? They'll tell you what back set, 2 3/8 or 2 3/4. Sometimes locks have or adjustable latches, but grade 2 locks like this that are called cylindrical type, which we'll get into at some point, do not work on latch bolts that can be adjustable. Now, the hole for your lock, if you just imagine, goes right through the door here. So this hole is right at the opening here. If you were standing on a ladder and looking down at the top of your door, it would look like this. Your hinges would be here, and the door would swing this way. Well, that back set dimension is measured from the edge of the door to the center of that hole. The center of it. However, doors can be square-edged or they can be beveled, meaning when you look at the edge of your door, it could either be at a 90-degree angle to the face of the door, or it could be at a 87-degree angle or a 3-degree angle, depending on what side of the door you're standing on. What that means is your door can look beveled like this. So if you are walking around, compare the door, what the door edge looks like. Do you notice? Have you had any geometry in school? Okay, so but do you know what a 90-degree angle is? Okay, so there are tools called squares. It's a square. You could take a square and make sure if it's an adjustable square, or you make sure it's set to 90 degree, or common framing squares will just be at 90 degree, and you can put that right on the edge of your door, and if it's all nice and tight, then it's a 90-degree angle. But if you can see that there's a gap, then it's not a 90-degree angle, meaning it's beveled. The door actually has a bevel on it, so that when they've cut the edge of the door, they've not cut it flat. They've actually taken the tool and set it on a 3-degree bevel is what it's called. It's a 3-degree bevel. Or 87 degree, if you think of it, 90 minus 3. Okay. Now, the back set, though, is measured not from the edge of the door in the sense of what's the edge of the door if it's a beveled door. Is it from this side of it or this side? The big side or the small side? So the definition of back set is actually where it's measured from the very center of the door to the edge. Okay? So if you were to measure this latch bolt, which would be 2 3/8, if you were to measure 2 3/8 from here to here on a beveled door, if the door was already drilled with the crossbore at 2 3/8 back set, you would not be able to measure on this door 2 3/8 to find the exact center because the door is beveled. On this door you could, which is square edge. So you have to be mindful that the door could be beveled. you're going to be a 1/16 of an inch. One little line on the tape measure, high, above it or below it. It's not going to matter at all, because you'll know. You can test your door for square. But about the latch bolts, the bottom line is, this is a 2 3/8 latch bolt. This customer is ordering 2 3/8 because he's drilled his door at 2 3/8 from the edge of the door. The other common size is 2 3/4, which would be the standard on a commercial lock. Residential standards are 2 3/8. More common. It can be 2 3/4. There's very little cardinal rules. We talked about a couple of cardinal rules last time about fire-rated doors. But the backset dimension is not a cardinal rule. It can be anything. There are manufacturers that will sell you, like Schlage, they will sell you an extension piece that will allow you to go to 5-inch. Back in the 1950s and 1960s, and in fact the home that I grew up in, had its hole in the center of the door. Because back, the design at that time was really large trim pieces that would go underneath the lock. So you'd have a really big escutcheon plate, they're called. Think of a big dinner plate that's mounted in the center of your door and the knob's there, but it's a really decorative dinner plate. It's got trim, it's got all kinds of grooves on it, and it looks really fantastic. So what happened was, the manufacturer stacked a series of the links together. You could use this and then use an extension link to get to 5-inch. If I added another one, now I'm going to be at about 7.5-inch. And if I kept going, I'll get to the center of the door. So that when we took the lock off the door, all those links came out of the edge of the door because they were stacked. Because the design back then was so cool to put the knob in the center of the door. You don't see that hardly ever at all anymore. But if you are, in fact, in Glenview where you grew up, how homes built there would have those old locks from the 1950s and 60s, made by Schlage or by Arrow as well. So 2 3/8 and 2 3/4 are common. 5-inch is common, not uncommon, I should say. There's a lock manufacturer that will make a 2-inch backset as well. 3 3/4 is not uncommon. Why do you need all these different backsets? Well, it could be for aesthetic purposes, like we just said. You just want the knob in the center of the door, so you increase that backset dimension to accommodate. Or there could be other reasons. Think of, have you been to a hospital recently? Have you gone to no, okay, so you've not gone to visit anyone. In hospitals, they have, and the next time you're in a hospital, be aware of the locks that they have on the doors. They will have they'll have latch bolts in the edges of the doors, but they'll have these long paddles that you can push or that you can pull to retract the latch, to pull that back so that the door will open. Those units are generally at 5-inch backset, very common. 5-inch. Don't have to be 5-inch, but they're very commonly 5-inch. That's because they're called hospital latches. The point of a hospital is cleanliness. So when the nurses and the doctors who are constantly, you've not been in a hospital lately, but they're always sanitizing their hands. What's the last thing you're going to do after you wash your hands? Go touch a dirty doorknob. That's the last thing you're going to do. So they have these these push and pull latches so that they can literally just hit it with their elbow and go in. And conversely, they can pull the door open as well. Because those devices are relatively large, it would be advantageous if the center line was further away from the door frame so that you have more room to actually work the knob, work the paddle that's there. If the paddle was very close to the edge of the frame, which is called the jamb, it would not work as well. You need operating space so that you can just push with your hands to make that open. So 5-inch is not uncommon as well. For this lock, you're going to have 2 3/8 and 2 3/4. That's it. Okay, but there are other backsets. Now, again, this customer ordered the lock without a strike plate. Otherwise, they would have a strike plate. This is a kind of little cool tool. This is called a castle nut wrench. They used to be made of metal. Now they're made of plastic, and that makes sense if you use your imagination. And many things in hardware are named after things that you can that are familiar to you. You've seen a picture of a castle. And in fact, you were just in London. You may have seen a castle. Okay. What does a castle have along the top of it? Well, it's got those pediments. It's got those brick structures. If you use your imagination, you can see why they'd call that a castle wrench. Okay? At least that's what I think of it. So the Schlage AL series lock, again, lots of things can be derived from a part number. So we are going to work on this lock from a keying perspective. We're going to get rid of the parts that we don't need. So this lock has come with not only its latch bolt, its strike plate if it came with a strike plate, but it also came with its screws that you need to attach it to the door. But it also came with the keys that operate the cylinder. Okay. So what we have here is we have a 53 function. If you remember the part of the part number 53, if you look at the Schlage catalog, you'll find a list of all of their functions. And this is a strange concept to really think about functions, but let's talk about functions. At home, you have your bedroom door. And you can set the inside of your bedroom door so that you have... What can you do to the inside of your door?
Well, to the inside of the door.
To the inside of the knob.
Okay.
Yeah.
You can change the pins.
Well,
you can take the whole thing apart.
You can. I hope you don't do that. And if you do, remember how to put it back together.
Yep.
But if you want to keep your sister out, what do? Isn't there a turn button on the inside?
Yep.
Okay.
Lock.
Okay. So you can set that lock into a temporarily locked state. That's a function. That function happens to be called a... When you're in your bedroom and you want to keep your sister out, what is it that you are accomplishing? Privacy. You have privacy. You're changing your clothes, you're getting ready for school, you require privacy. Guess what they call that function of lock? Don't overthink it. It's called
Privacy.
a privacy lock. Now this lock, and I'm pointing at the box, is a 53 function. The code by Schlage is a 40 function. So if that was an AL10, if that was an AL40, it'd be an AL series lever lock, grade 2 levers, but a push button here, no key out here, and it would be a privacy lock. You might have, I don't remember your house well enough, but you might have a closet where you all keep your linens, your towels, your sheets. Okay. Would there be any need to have a key on that door?
No.
Realistically, no. Would there be any... It's a closet.
Yeah, you just...
Would there be any need to have a privacy on that door? Not really. There's no one... You can't even walk in there and close the door. So you never need to put that button. That's a passage set, also known as sometimes as a... You just said the word. A closet function.
Okay.
You can also call them closet functions. That people would know, oh, that's a passage. It's just got 2 levers on either side. No keys, no knobs, no push buttons, no privacy, no nothing. They just always operate. There's other specialty functions that exist that aren't privacy or passage, but they're related to them. In the keyed functions, there are then a variety of different types of keyed functions. This is a 53 function, which means it can act in different ways because it's multi-talented, and we'll go over that. But other functions that have a button on the inside would be an office function, where it's just a push button and a key on the outside. And an office function would work as a type of door that if you were in a, let's say, a car dealership, and you had all of the salespeople's doors, and you would go into your office, and you would have your client, but you could push the button so that you had privacy in the sense that you can't come in because I've pushed the button. The lever's rigid unless you had the key like the manager. But as soon as you exit, see how that popped out? As soon as you exit, it will then unlock the outside. So you just push that button on the entrance function for temporary privacy. That's called a 50 function or an office function. You can then get a storeroom function where there's no button on the inside, there's nothing. The inside's always unlocked. The outside has a key and it's always locked. What would be a purpose of that door? Well, an exterior door that you never want to accidentally leave unlocked. Like the door to the hallway here in the building, that, while it's not this function, is a perfect example of whenever that door closes, I want to know for sure that it's locked. So you put a storeroom function. That would be an 80 function, they would call it. Another function would be a classroom function, and I don't recall my grammar school enough to know what function of lock was on my door, but a classroom function would be where you have one side is always unlocked and there's no button. The outside has a key. When you put the key in, let's say right now it's locked. If you put the key in and turn it 360 degrees and take it out, now it's always unlocked. Until always unlocked. Until at the end of the day when school is over, the teacher would put the key in, turn it the other direction, take it out, now it's always locked. So you can set it into a passage function or set it into a storeroom function by control of the key. So a 70 function from Schlage is a classroom that can operate as either a 10 function passage or an 80 function storeroom lock where it's always locked. There's some other functions that they have that I'd have to look at the book to remember their definition. The 53 function, what we're driving at, can operate as a passage, right now a 10 function. I can push that button in, and now it's locked until I do this, and now it's a 50 function. Or it can operate as a storeroom, where it's always locked, it's always locked. So it's a triple function lock. And the 53 function is very common as a result. But because it has more functions does not at all mean that it's appropriate for your application. The function has to be appropriate for the application. Here's what I mean. In today's world, with schools that we live in and all the crazy stuff that unfortunately has happened, you can have a lock like this, similar to this, with a key on both sides. Okay? There will be a key in both levers. The inside lever is always unlocked, you can always exit. The inside of the classroom has a cylinder. It's always but the lever can always be used to get out. The outside has a key cylinder on it. This outside lever can be locked or unlocked. Depends on how you set it. You can, on the inside of that door with the key, control the function of the outside lever. So let's say something bad happens. Your teacher can go to the door without opening the door, without going into the hallway, put the key in there, turn it, pull it out. The outside lever is now locked. And you control that from the inside. But why would you want a cylinder on the inside rather than just a button? Because a button will lock the outside, right? You can go up and push the button. Well, you'd put a cylinder on the inside so the kids couldn't goof around. The teacher needs to have control over the outside handle, right? Not the kids. If you had just a push button, you could just, if your teacher walked out to go to the restroom for 2 minutes, you could lock her out or him out if you had just the push button. But if you had the cylinder on the inside lever, the kids couldn't goof around and, oh, it's funny, let's lock the teacher out. You can't do that. So that's a generic overview of the functions. Suffice it to say there are different designs that this lever comes in. This is called the Saturn Lever. Schlage likes its planets, or in the old days its Greek gods, or its Roman gods, I forget. Or their references to Greek mythology. They had the Olympia at one point. Well, Schlage also likes their it might be Roman mythology. This is the Saturn. You could also do a Jupiter lever and then a Neptune lever.
What about Pluto?
Pluto does not get its own lever from Schlage, not yet anyway. Although Pluto would be nice for a small little knob. I'd call it a Pluto knob. I've got some very old Schlage catalogs that have a lot of that old stuff in it. So this is called the Saturn. You can have this in many different colors and finishes, and we're going to talk about finishes in a future lesson. But this is what is called Satin Chrome. This is a 626 finish, but Schlage calls it 626. You may also, if you know the color, it might be called 26D or US 26D. Different conversation. This is Satin Chrome. This particular handle means that the trim is made of solid brass and that it has a satin chrome plating on it. It's been plated with a type of amalgamation of different metals. An amalgamation is when you take different items and put them together. It's an amalgamation. It's put it all in there, and now you have a new thing that's made of these subparts. So they will plate it with that amalgamation of metal, the plating, the satin chrome, and give it that color, basically. When you talk about locks or hardware, I don't like to use the word color. We would use the word finish. So finish means when you're complete with something, you're done, you're finished. Well, it's the same application for this. What finish is this when it's done? What is it when it's finished? But a finish will also help determine, in my opinion, when I think of finish, it will also help us discuss what is the material made of, because you've got the finish that's on the hardware itself, the color, but what is the base material? So the term finish, what finish do you want? Meaning, I take it to mean what's the base material made of, and what color do you want it to be? Color is a term that's, what color do you want? Well, I want satin chrome. There's no, I mean, in today's world, you can have things powder coated any color you want, and powder coating is a process of finishing. So you could have purple powder coated stuff, but finish helps us talk about. It's important to know what color the material is, but also what is it made of. A quick example would be if you've got here in southern Florida where we live, if you have a door hinge and it's made of steel, it's going to rust. So a lot of people will order stainless steel because stainless steel is a non-ferrous material, meaning it doesn't contain iron. Iron is what rusts. While there's still a little bit in there, it's very small. And then they make a much higher caliber of stainless that it will be very impervious to rusting. So when we're talking about hardware, we have to talk about what color do you want, but what is it made of? So if I was going to sell you a hinge, it would be really important for me to understand from you not only what color do you want, but what do you want the hinge made of? Because you might be a smart person and say, don't give me that steel hinge, it has to be stainless steel. I don't want it to rust. So a discussion of finishes has to really incorporate both that stuff. So in a lock set, you're going to have lots of different pieces of hardware. Here's my magnet. That'll stick onto the retracting or the housing hub that's down there, but it's not going to stick to the trim at all. Okay? It'll stick to a lot of things on here. It won't stick to this. It'll stick to that because there's steel. So right here, in what I just did, I can tell you there are 3 different base materials here. There's brass. This is made of brass. This, the chassis, is made of steel. This part out here is made of zinc. Zinc is a dense material that's actually quite heavy, but it's non-ferrous. There's no iron in it. It's used because zinc is very abundant on planet Earth, very abundant. It's durable, it can be worked and machined, it can be made into these shapes. It's less expensive than steel, and so there's zinc here. And there's probably other types of material in here, but we probably have it all covered in what we just did. So, maybe someday we'll disassemble this lock and put it back together, but that won't be today because we have to first learn how to just take the lock apart. So, the process of what we're doing here is we're going to rekey the cylinder. We're going to change the keys that operate it. This customer that we're doing here wants us to take all these locks and key them to his key. So he has a key, but it's not the one that comes from the factory. You need to have the key to get the outside lever off in order to gain access to the cylinder. If you didn't need a key to get the lever off, anyone could then just pull the lever off and manipulate the inside of that lock to get in. That is no security in that. So this lock has been designed to require a key, which will allow you access to the door, obviously, but allow you to take it off. So in order to remove the lever with this is where we start the mechanical part, you have to put the key in the cylinder. And it works. And if the latch bolt was installed, it would retract the retracting hub. That's what's going to pull the latch bolt back to make it go back. That little fork that's there, I can get it in there without taking the inside off. Okay. You need the key to take the lever off. You'll always notice, as you are now learning more about locks, there's a small little access hole here. There's one over here too. Those small little access holes here and down here allow us access to the tab, to a spring-loaded tab, and we're going to look at it closely in a moment, that keeps the lever on its stem in place. When you have the key and you put the key in and you turn it, when the key is turned and held turned, it makes room to permit you to use a tool to depress the tab so that you can pull the whole lever off. So since we've got the lock here, I want to talk about the cylinder and how that would work. On the back of the cylinder, there's a flat piece of metal called the tailpiece. The tailpiece, the cylinder is here. The tailpiece goes into the body of the lock set. Okay? The tab sits here. The tab sits here, let's say. So if you were to push on that tab, it will not go in. If you were to push on the tab, it will not go in. But when I put the key in the cylinder and I turn the tailpiece from here to here, now there's some space there that will allow the tab to be depressed. Here it's no good, but when I put the key in and then turn the cylinder, turn the tailpiece, now we'll go in far enough. That's exactly how this works. So we can take that and push on it. There's nothing you can do to make that come out short of breaking the lock. But when you take that and push on the tab, what you want to be careful of, don't mark the lock. You don't want to damage the lock. Go ahead and push it straight. You might feel something move a little, but it doesn't move enough. Now, go ahead. I've got the key turned now. Now it's turned. Go ahead and push. Does it move a little bit? You feel a little bit of movement? Let me try it. Yeah, I can tell that you did it, because it came off. Nothing? When I do this, oh yeah, oh it definitely moves. So this is the part of being a locksmith that requires a little bit, of practice and skill. But you put that in there, you turn that, and you hold it turned, and you're going to take your little tool and push that. I demonstrated that poorly. So you've got that turned. You've got the key will be turned. I'm going to hold it turned. I've got it at 90 degrees in my fingers. When I get in there, I can then push the entire lever off with my hands by just pulling it off. And sure enough, it comes right off.
Oops.
So, before we look at the cool stuff, let's look at the tab. Now, you see that horizontal slot that's in there? That's where the tailpiece goes in. Horizontal slot down to the throat of that tab, in the throat of the lock, is where the tailpiece goes in. With the tab, when there's no tailpiece in there, it'll just depress. That's the little hook that keeps the lever on, because the lever has a groove in it. And that's what the tab sits into. And will prevent the lever from coming off. That little groove that's on the inside of there. Oh, where are we at? Here we are. There's it's hard to see, but it's right here on the back side of where that pin is. There we go. Little groove in there. We can demonstrate that easily when we put the cylinder in. You can tell that it's going to turn because that whole spring-loaded clip will move. When I put that cylinder in there, that thing is not going to move because the flat bar of the tailpiece is preventing the C-clip from moving. That's exactly how that works. That's what keeps this knob on, this lever on. Okay. Now, this is a piece of plastic. It's called a retainer. It's very important to go back in there because it helps the cylinder stay in place. When you get these, you have to be sure that they go back in. It's suffice it to say it's there for a reason. Make sure it goes back in. That's the cylinder. That's the key. What do you think?
We dissected a knob, or a lever.
We did. Well, someday we'll dissect it by taking all this apart, but that's I don't like doing those.
Next class.
Yeah, it'll be a future class. Now, if you remember us talking about our keys, what can you tell me about this key, if anything? I mean, what can you tell me? Tell me anything about the key. And it doesn't matter if you remember or not.
It's a Schlage.
How do you know it's a Schlage?
The head, the shape of the head.
Yes, and the fact that the box has Schlage. No, in all seriousness, discussing identifying key blanks is important because the shape of that key blank is a Schlage shape. And other manufacturers who will make keys, copies, you know, make Schlage type keys, will emulate the head of that. So one of the first step of key identification, as we discussed last time, is identifying the key blank. What does the head or the bow of the key look like? The bow rhymes with toe. The bow of the, what does that look like? So that shape tells us it's Schlage. So if you're working on a cylinder and you don't know anything about it, and if you've got that key, it's most likely if it's a Schlage shape, it'll tell you, okay, I'm dealing with a Schlage system. And as we talked last time about the different keyways that can be run, if you recall, there were 7 keyways in the Schlage standard multiplex system. What else can you tell me, if anything, about that key when you study it? You identified the head of the key accurately. What else is on there?
I'm trying to see what the cuts look like.
Say, you grab the key and hold it.
Okay.
What information's on there?
That it's a 6-cut key.
Okay, how do you know it's a 6-cut key?
Because it has 6 cuts in it.
Okay, how else would you know that?
And this, I forgot what it's called, the bitting.
The bitting, excellent.
It has 6 digits.
It's got 6 digits in the bitting. It's got 6 cuts, 6 bitting. What else is on that key?
It's a 6-5-4-4-5-3 bitting.
Keep going. Move on from the bitting now. What else is on there? Not the bitting.
A C.
There's a C on there. That tells us that the broaching of the cylinder plug and that the keyway that key is a Schlage C. If you recall, we talked about C, C, E, C, E, C, E, F, F, G.
G, H or something.
There was
There's no G, H.
C, E, C, E, F,
S,
G,
S.
F, G. We're missing one. But the point of the matter is, you now know it's a C keyway. The keys identified that. You could go get another C key blank that you might have in your stock and make it physically go in there. And it won't work, but it'll go in. Then you'll know it's a C keyway. So you've derived a lot off of just looking at the key what we're dealing with. Whether it be Schlage or Corbin, Russwin, or Sargent, they will all give clues when you study the key blank to tell you whose lock you're dealing with. Now, this cylinder is a 6-pin cylinder. as evidenced by the key. There will be 6 chambers in there. This is a cylinder that has different components. There's the plug housing. There's the plug. There's the cap, the retainer cap. There's a retaining pin and a spring and a tail piece. There are springs, there are driver pins, then there are bottom pins. There's this brass cap up on the top. That's right. This brass, this piece of brass, I forget what they call this. There's a term for it, but this piece of brass in there has been placed in there and then pinched down so it all stays together. So there's lots of pieces that are in here. But it's all really easy to start to grasp once you start to exercise or to practice using these. Now, I'm going to take some of the stuff out of the way here. This we need. That will move over here. So you can put that key in, and you can certainly make it work. And it's going to work just fine. With a lever lock, it's important to know the orientation of the tailpiece. This is vertical in relationship to the front of the cylinder. But you'll notice that that slot in there is horizontal, where the tailpiece goes in. That tailpiece is vertical. Well, in a lever lock, the cylinder actually lays on its side. So a normal lock, the teeth would be up like that. But in this case, the cylinder lays on its side. So that's how that works. So you have to know when you're working on lever or knob locks the orientation of the tailpiece. Why is that important? Because when we take this off right now, you got to know how to put it back together again. Okay. So the first thing to do, and this little poker tool here is going to be something that you'll use all the time, and it's always helpful to have paper towels around because there's grease on all of this stuff. So what you're going to do is this retaining pin is spring loaded. There's a spring inside of there. So when I push on it, I can tell that there's a spring in there. So what I want you to do is I want you to hold that down so that you can then unthread this cap. See how I can turn that? When I've got the pin held down, go ahead and you do that. Stand up, move around, do whatever you need to do. First of all, I want you to be mindful. You have a sharp instrument in your hand. I have seen someone trying to work on something in their hand, and the tool slipped and went through their, whatever this part of your hand is called. So you have to be mindful of what direction your tool is pointed in relationship to yourself. Learning how to be a locksmith is also part of learning how not to harm yourself, which you will do. And then you will learn how not to ever do that again because it will hurt. So be mindful of the pressure that you're applying, where you're applying it.
I remember stabbing myself in the finger with a pin. I was doing the same thing. I was trying to get the thing open because it was like in a... I was curious of what it was. So when I'm trying to open the plastic thing, it suddenly opened, but then the momentum of me trying to open it went psh, and it stabbed me in the finger.
Yeah. Yeah.
So,
being mindful of how much force you apply and what direction that's headed in is important to know so that you don't hurt yourself. So let's talk about the parts. You've got the threaded cap, you've got the tail piece, there's the retaining pin, and there's a spring underneath there that's underneath that pin. I want you to hold that pin down. Maybe, but you'll figure it out. The access area is better this way because you can bend that tool down a little bit. Over here you can't really bend, you got to lift it way up. Anyway, but you'll figure that out. You'll figure that out with time.
So twist it?
Yep.
But which way do you twist it? Clockwise?
Lefty-loosey, righty-tighty, so we're going to remove it. Lefty-loosey to the left. Counterclockwise.
Okay.
Sorry, I should have used the technical term. You keep going until it comes all the way off. And you'll realize that you've got to hold that pin down. And what you don't want to do is lose any parts. because you're on the job site and you don't have any parts left over. So if you lose any of these parts, you won't be able to put it back together. That's it. All the way up till it's obvious. There you go. Now, carefully lay the parts out in your work area. Right in front, right on the top of the kit. Now, pull that pin out. What was the other, and that will probably roll off, but let's, yeah. What was the other part I told you about? There's a spring inside of there. So what we do with that...
Just flip it over.
Yeah.
No, don't go.
Definitely don't want to lose it.
Don't leave us.
So now, you've got the tail piece off the back of that.
So...
If you're going to be a locksmith in the field, you're going to want to have some of these extra parts because they do get lost.
Yeah.
An old locksmith customer of mine told me about a trick that he used to do. When he would sit at his workbench, he would have a large towel stapled underneath his workbench that would lay in his lap so that any parts that jumped on him or flew out would generally fall in his lap, not on the floor below him. Okay, not in his shirt and whatever. So we've got this disassembled, and what keeps the cylinder plug on the cylinder housing is that threaded cap. The threaded cap keeps it on there, meaning that if I were to put the key in here and turn it, that threaded cap has been removed, so I could now pull the entire plug out. But we don't want to do that because there are springs up in the Bible. This part is called the Bible. Little ones. With driver pins. Then there are bottom pins that are in here as well. So there are 6 chambers. 1, 2, 3, 4, 5, 6. Number 1, with a conventional key system like this, is measured from the bow of the key. This piece right here is called the stop, or the shoulder stop, right there. So from the bow or the shoulder stop, 1, 2, 3, 4, 5, 6. So if I say the first chamber, I mean here, not here. Other key systems, this is number 1, but it'll be some time before we get to those. This is number 1 on this key system. 1, 2, 3, 4, 5, 6. That's the shoulder stop. That's the root of the key. That's the tip of the key. The overall height of the key blade is from this flat area that's not cut down to the bottom. Okay. The cut, the depth of the cut would be measured from this uncut portion to the root of the cut, the root of the cut. We can't really measure that because there's nothing there, but what we could do is measure from the uncut portion of the blade to the bottom of the key blank. We could then measure the root to the bottom of the cut and subtract that from the overall dimension and then know what our height of our pin is. So that'd be an easy way to do it. However, we don't need to do that because we have the bitting. And I know the bitting of the other cylinder that we're going to, or the other key that we're going to fit this to. Now, the next part of repinning a cylinder involves removing the cylinder plug from the cylinder housing, the plug and the housing. That requires a tool called a plug follower. This is my plug follower that's almost 20 years old. I've not lost it in all those years, and I'm happy to have my happy little tool. There is rules when it comes to doing locksmithing, and those rules are based on the system of the lock that you're working on. We're working on a Schlage AL system, as you know. The rule with this is when you insert the key to pull the plug out, you have to turn it like 45 degrees to the right. To the left would work as well, but because we're right-handed, we're going to go to the right. 45 degrees. Once you have that turned at 45 degrees, you can use this end of your plug follower, not this end. Use this end of your plug follower and hold that straight where the cuts are at 9 o'clock and 3 o'clock, if you would imagine a clock. You hold it straight like that, you'll then be able to push the cylinder housing, slide it onto the plug follower, just like that. If you turn the key more than 45 degrees, the pins that are in the Bible are going to get caught on that groove. So you have to slide it out. You can't slide it out over this area. You can't slide it out over this area. But you can slide it at 45 degrees. It'll slide right out. This part of keying locks takes practice. 0 degree, 45 degree. I can then take that and push it right back in. Okay, but since we need to repin it, it's got to come off. If I were to pull the plug follower out, what's going to happen? What's the purpose of the plug follower?
I think to keep, I'm not sure, it might or might not be true, but if you take it out, things might fall out of this.
That's a guarantee things are going to fall out. Because what you have is you have springs up here in the top, and then below it is a driver pin. It's basically a bottom pin, but that it's square on both sides. The plug follower is there to make sure that the tension is kept on the spring so that the driver pins aren't lost. If I just pull that out, everything's going to come flying out of there. Everything's going to come flying out. Now, what we have over here now with the plug, the cylinder plug, we can really study that. And you can see from that cylinder plug that when the pins are not in there, when the key's not in there, those pins aren't flush. But when I put the key in there, all the pins are even.
Shear line.
There's a shear line created. If I were to replace one of these pins with a different pin that's not the same size, it's obviously not going to work because a shear line will not be created. There has to be an even line from the top of the plug to the inside of the cylinder housing so that the pins are all lined up even and the plug can rotate. Because my pins up here in the Bible and my pins down here in the cylinder plug have to be even in order for it to rotate. If the pins are not even, there is no amount of force that you can apply to the key to shear those pins for it to open. Impossible. The key would tear apart first before you would split all those pins in half. Okay.
Remember how we, like, with the other key when we were working on the other machine, where we, like, used the wrench to turn the key when it was...
Oh, yeah. Yeah, so we actually demonstrated with a set of pliers how we could tear the key before the cylinder plug would turn if it wasn't pinned properly.
We killed it.
Oh, we killed that key. Oh,
We
for
killed
sure.
the key.
So the system that we're doing for this customer is a 5-pin system. So now we have a little bit of a problem because we have a 6-pin cylinder. But his key is only a 5-pin key. The 6-pin key is physically longer than a 5-pin key. I mean, it's literally longer. We could measure the length of the blade and it will be longer. However, there's really no problem because up in the Bible are 6 pins and six sets of pins and 6 driver pins. And what I can do is remove the 6th chamber, its spring and its driver pin, so that his 5-pin key will work. And what I'm going to do, I always use this end of my plug follower as the front of the cylinder because you might forget what is the front of the cylinder if you look at this. So I always use this, so I always know that this is the front of the cylinder housing. So when we look inside of here, When I pull that plug follower back, what do you start to see show up right there?
The driver pin.
You see a driver pin right there. As soon as I pull that back a little bit, that's the 6th chamber, because that's the front of the cylinder. I pull that out, and you see that driver pin. Now, if I were to go any further, hopefully you heard that, a little pop, and then what came out was my
spring driver pin.
and my driver pin. My spring and my driver pin.
It's very small.
So I would normally save these. It's just that I have 1,000 of them, so I throw them away. We've now dropped the 6th chamber in the cylinder because our client does not require 6.
Now, these are pins.
So what I'd like for you to do is to put those pins away into the kit where they go. Now this is a universal kit. This is a 3000s kit that has charts up in the top of the lid, but I've already marked in black marker 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. Those are Schlage.
Yeah, Schlage.
Okay. Yeah, so you've got your chart there. So look at your first pin. What's the number of your first pin?
6.
Okay, so drop. Let me just show you, then you're going to do it. Put your finger over 2 through 6 and just dump that first one out and then put it in the kit where it goes. And while you're doing that, I'm going to go get the key that we're going to key this to. We're going to talk more about that shear line. Sometimes you got to tap it because there's lubricant on that and it'll keep it from falling out. There you go.
6 pin.
Oh, if you wanted to be fancy while I'm getting those keys, you know what? Let's do that so you can demonstrate that yourself. Looking at the chart in the kit itself, let's just give the audience a reference of what we're talking about. In this kit, there's a chart in here. The chart for and a Schlage reference is in here as well. Okay. Now, where's Schlage? There's Schlage. What is the size of the 6 bottom pin?
0.255.
Okay.
Just search.
Hold on. Don't put that away just yet.
Nope.
We're going to take out my best friend here.
It's a favorite tool.
This is my best friend.
To measure.
We're going to take our caliper, and you're going to measure it overall. And when you're done, it needs to say 0.255.
Yep.
With your right hand and your thumb.
Okay.
You make sure that that's 0.255, and you measure the rest and make sure they're all good. Was that pin faithfully 0.255?
Still trying to measure it because it keeps slipping out.
That's okay. Take your time. It's not easy, and you do have to practice to learn. But the point of the matter is why to do that is because you can then determine, if you don't know the size, you can always use your caliper to determine what you're dealing with. Okay, so I've cut my key on my key machine that's not working very well because the spring is broken, but we'll have that fixed next time. How did the pin get measured? How did it look? Alright, so let's...
I put the 6-pin in it.
Alright, so did the 6-pin measure to .255? Which one do you have there now?
I have I think it's 464 it was, the key.
No. What size you got there? 0.2?
It's hard to get it super because...
It's okay.
Is it to the tip of the pin?
Yeah, right to the tip.
Yep. Because that's small.
So here.
It's slipping out.
It's okay, here. Let me give a go.
Okay.
So I'm going to hold it in my little hand here. And I'm just going to measure it. And yeah, it's definitely hard to get it right centered. But when I do that, when I get it pretty centered, actually, we can use the wider part of the tool.
Oh, you can.
It's helpful to have smaller hands. When I measure that, it's coming out to basically 0.24-ish. What's 0.24 on this, on the Schlage chart?
Nothing.
Well, sure it is. 0.240 is the same as 0.24. What size is a Schlage? 0.224 or 240?
0.240 is the bidding number 5.
So it's a number 5. We're going to put that right in the 5. We could do that with the rest of these, and sure enough, the second chamber is a 5. You're good to go. You take the rest of those pins and you put them in the kit where they go. It's like a piano, and I know you understand that. That's it. Go to your next one. Oh, one little thing I do is I'll slide the key out a little bit, and the little cuts on the key help. Yeah, it kind of help get it started, and then I can just rattle it a little bit, and it'll fall out. There you go.
Did I just take out the wrong one?
Well, you can test that. The wrong pin fell out. What you can do is you're missing a pin from the 5th chamber. The 5th chamber is a 5. If you put that in there and it's flush, then you know you've got that 5 pin. Yeah, it's good. So your last 3 pins are 4, 5, and 3. 4, 5, and 3. So you can just put those away. And now you'll remember I dropped that 6th pin because the key that we're keying it to is a 5 pin. 3, 2, 3, 2, 2 is what that's cut to. I cut that on my ProLock Blue Punch machine for Schlage, which works really well. Except there are 2 springs that hold the Blue Punch, the handle up. One of the 2 springs broke, which in almost 20 years, it's the second time that's happened. So I've got the springs on order, but it will still work.
I'm having trouble looking for the 5. Oh.
Nope.
No.
It's just well, okay. It doesn't matter. Here. But what you can find are all the decimals on here, right? So all you had to do is look for a 0.24, and it goes bigger as it goes along. The pins that have the T on them are your top pins, which are your master pins, really. The pins that have the B on it are your bottom pins. The bottom pins will always have the points on them. So now you have the old key taken out. I have 100 pounds of cut keys, so that's going straight in the garbage. The next thing to do is to now either, if you know the bitting of what I've cut, you're in good shape. You can gauge it on a key gauge, where they make a sliding key gauge where you can determine the cut of these. You could take your caliper and measure the blade height, which is roughly 0.345, and then measure the root cut and deduct that from 0.345. You'll know that. However, this is just, the bitting is, and I'm going to write it down for us.
3, 2, 3, 2.
Yeah, that's right. 3, 2, 3, 2, 2. So that's the bitting for this lock that we're doing. And we're just going to take that and put it up here because we don't need any master pins. Now your job is to load the cylinder plug with your bottom pins. It would be helpful for you to put the key in while you're doing it for a couple of reasons. You don't have to, but it would be helpful. Why? It gives you a little more of a handle to hold. Plus, when you put the pin in, you'll immediately know if it's good or bad. Now, if you're doing a big job, and when you come back next Saturday, I'll give you the whole case of locks. And then if you look over here on the shelf, there's 5 more cases of locks. And just sit in key locks all day.
That's a lot of locks.
Oh, that's only half of the locks for the one order, and there are 5 other orders. Lots of key work to do.
Why does this person want so many locks?
That's life in the big city.
3, 2, 3, 2.
So we use lots of 2s on this job.
2.
Okay. Now your experience as a locksmith, and as you gain experience as a locksmith, you're going to take that cylinder plug and you're going to say to yourself, well, do those pins look even? Do they look even to the point where it's going to actually work? And you'll discover when a pin is good and when a pin is really not so good, because it'll be too low or too high. My experience is telling me that these are good enough, because between the inside dimension, if I pull that out just a scooch, you can start to see that driver pin. The inside dimension of the cylinder plug and the diameter of the plug, they're not the same number. This is a little smaller. It has to be a little smaller or it won't fit in. But the difference between the inside dimension and the diameter of the plug permits or tolerates the pins not being perfectly exact. And my experience, based on knowing this key system and this plug and how this is made, this will work just fine. Now, the part of this that you're not doing by yourself yet is putting the plug in, and taking it out. So with this system, we have to have our key turned at 45 degrees so that the pins that are up in the Bible will slide over this smooth area here. If I were to put it in straight, the pin in the Bible in chamber 1 is immediately going to fall into the pin of chamber 6 in the plug. That's going to cause the cylinder to seize. That's why it's got to be rotated a little bit so it slides over a solid smooth area. So I'm basically just going to take that and slide it and push it right until my plug follower falls out, which I don't like it to fall, and I'm not going to let it fall because I don't want it to fall and dent the edge of this. It makes the tool less effective. So I've got the plug follower out. My key is still turned a little bit, as you can tell. And now the moment of truth. Take the key out. Oh, it works really nice and smooth. Really nice. You can go ahead and try that. Now, be mindful that when you put the key in, you could then push the plug out because you have a shear line. If you did that, everything will pop out. So you have to be sure to not pull the plug out as you're testing your key blank. If you do, we just have to put it back together, and then it takes a 5-minute job and turns it into a 10-minute job, which you'll do eventually. Push it all the way in. Yeah. Okay. Okay. Now, before you pull it out, hold on. You've tested it. You can do that. Hold on. What you're trying to do is to keep the plug with your thumb. What I do is I use the tip of my index finger and I push. These guys pull the key out. This guy pushes. You see how my index finger articulates? Extends out. I'm using that to push the key out, or to pull the key out. You go ahead and you try that. Use these two guys on the head of the key, and then use that tip to push. Hold on. It is, and it takes a lot of force. It's not easy to do it, and that's where the practice will come in. But when the plug is live like this, you have to be careful not to pull it out. And I'm really tempted to pull it out, but we're going to do that next time because I don't want to. We'll continue on with an anatomy of the cylinder plug next time, but next time what we're going to do is we're going to force you to have to learn how to put it back together, which will then reinforce, oh yes, okay, these theoretical concepts of what you're saying about the pin and where it has to be located all now makes sense. So now, this key works really good. You now then have to put it back together. So you've got 4 parts. Do you remember the order in which you took them out? Put them back in the reverse order. The last thing that came out is the first thing that will go in now.
So that
yeah,
was this
your retainer spring will go.
That there.
Your retaining pin will go in, and study it. Do what you're doing. Why are you studying it? Tell me why.
So which end goes in
So
first?
what you're trying to do is to figure out how is it different. And it turns out it's symmetrical, isn't it?
Yep.
So you can go in either way. Yep. Hold on. That fell all the way in. That should not have happened. Where's your spring? Oh, you okay. Now, this would have taught you your retaining pin isn't stuck out. It would be sticking out if there was a spring there, but what that obviously told us is that you put the spring in that wrong hole.
Yeah.
You go ahead. We don't want to lose that because I don't even know if I have any more of those. Oh, I had a dream last night that in my pin kit I had like 500 retaining pins. I don't know why I had this strange dream, but I said to myself, why in the world would I have so many? It's a lever, so your tailpiece has to be vertical. There's 2 ways to put this in. The pin has to go into one of these notches, right? You put it in such that it comes together so that it's vertical. Can't go that way. But if you tried to do that, you'll soon realize that it can only go on one of 2 ways. Yeah, you got it. Put it in the other way. Okay, hold on. Leave it. Put it how you had it.
Like this?
No, the way you just had it in. Yeah. What orientation is the tailpiece? It's horizontal.
Oh.
It's horizontal. It could be vertical too, but it's horizontal in relationship to the Bible. The Bible's here. It's horizontal or perpendicular to the Bible. But we're doing a lever lock, so a lever lock has to have a vertical tailpiece. So all I did was move it from that notch to that notch.
Like that?
Yes. Now, you want to be careful because you got a pin that's got spring tension. That threaded cap needs to go on, and you're going to need the tool. So you are literally reversing what you did earlier. Your thumb control your cap, push the pin down, and lefty-loosey, righty-tighty. So to tighten it, you're going to go clockwise. Yeah? Clockwise. You got it. You get it. It just takes practice is all this takes. That's got to be held down. And as you turn, yeah, keep going. Oh, you got it. So what's happening is the pin is spring-loaded, right? Okay, and that's doing its job. So you just have to learn how to keep it depressed and rotate that cap until it's all the way down. Now this is where you be careful, because this is where you're going to stab something. You don't want to hurt yourself.
I was not making any progress that whole time.
Okay.
What?
So that cap's going to go on. I'm going to take my little tool. I'm going to push it down, and I'm going to hold it down. And I'm just going to get that cap started. I went counterclockwise just to seat it flatly, and I just rotated it. So now it's nice. But no, you were making no progress.
It just came out.
What I do? Put that on there. Use this as a handle. Get it on there. And now I'm good. But whatever. You'll learn it with time.
I don't think. I'm going to try to get...
Yeah, some people will have to do it their own way. Now it appears to be flat. That's good.
So we want it to be flat, right?
It's got to be flat. It's like a nut and a bolt. A lot of being a locksmith is having...
What am I doing wrong?
Nothing. You're not doing anything wrong. You just, you have to fight through it. You have to study it. You have to say to yourself, why isn't this working right? And then learn, as a result of your analysis, what do I have to do differently to make this work correctly?
The only issue I have is that
Let's do this.
It keeps slipping off.
I'm going to hold the pin down. I can't see that well. And you're going to turn the cap. It's not even. You can see it's not even. The cap's not even.
Oh no.
My pin is probably my tool is probably in the way. And what I'm doing is I'm turning it a little bit backwards. Oh, you know what? There's also a cheat that I have too. I can do it without the tool.
Technical. Wait, what? How?
Oh, maybe I can't. I definitely can. Hold the phone. What's going on here?
Technical difficulties.
That cap is giving us a little bit of trouble on that. So what I'm going to do is see if I can smoothly thread the cap on. Well, the cap goes on, definitely. The cap goes on its own. So we'll put that retaining pin back in there. We're going to put the tail piece back on vertically. Because I don't have the eyes of a 20-year-old, we're we go. So that's on, and I've tightened it all the way down. And the rule is tighten it all the way down and go back one click. That might work perfectly. Go ahead and test that. Tighten it all the way down, back one click. Go ahead and test it.
Wait, tighten it all the
way. No. I've already tightened it all the way down. You're going to test the key. It's awfully hard, isn't it? Okay, so what that means is our cap. So what you also have to do when you're doing that is make sure by turning it rotationally that it's actually perfectly vertical. So this is too tight, so that means I've got to back it off one more hole. So I've turned that one more little click. Now try it and see if it's better.
A lot better.
Okay, let me try it and see if it's perfect. Oh yeah, this is perfect. The key comes out correctly. So what we've done here is we've rekeyed that cylinder to the customer's required key. Now, just like putting the cylinder plug back together, we have to put, or the cylinder back together, we have to put the lock back together the same way. So we took the cylinder out of the lever, we took the plastic retaining piece, that's got to go back in. This now all has to go onto the lock, and in order to do so, you want to have the key in the face of the cylinder, and you can kind of use it as a handle. Then you take this whole rigmarole, and everything's got to line up just perfectly, and when it does, it'll snap right on into place. So what I did there was, as I was pushing the cylinder down, as I was pushing the lever with its cylinder down onto the stem, I was also turning it slightly so that the spring-loaded clip inside had room to be depressed to allow the lever to travel all the way down, and then the clip to seat itself in the little groove that's in there. Turn it, push it, it clicks. Oh, you didn't see that. Push it. Turn it, because you've got to turn the tailpiece out of the way for the clip to depress so that it can then spring back and rest in its groove inside the lever. And what you always want to do is pull on that, make sure it's seated and not falsely on there. You don't want it to fall off in your customer's hands. So it just took us an hour and a half to key one lock. We lost money on that job. It took too long. So now, once you understand the overall concept of how a cylinder works, meaning you've got the different components and how they all conspire to make a cylinder that works correctly, you can then start to say to yourself, how can my knowledge now permit me to work on this? So the next step in this sort of situation is literally the practicing part, where you have to sit and key cylinders and pin them, take them apart, figure out what has to be done. And to become a locksmith is a confluence of theoretical knowledge and practical knowledge. You can understand it, that's great, but if you can't demonstrate it, then you're probably not a locksmith, or at least one that makes a living as a locksmith. So we put this lock back together. The next step that we're going to do is the practicing of this sort of stuff, but also we're going to go back to our key cutting sort of work. But what we've done is on an actual lock, we've demonstrated the construction of that cylinder, which is called a pin tumbler cylinder, the parts that operate inside of there are called tumblers, and there are different tumbler types. And that's where we are. That's what's got to be done next. Great. So we did it. Teamwork. Have a good day, everybody. Thank you.